Let's look at the normal distribution. And we're not going to look at just any normal distribution. We're going to look at the standard normal distribution. Now, there's a few things you should know about the standard normal distribution, the standard normal curve. First of all, the shape should look familiar. It's a bell shape. That's our normal curve. Has that bell shape. And in fact, we know a lot about the areas underneath the normal curve because we've studied the empirical rule, which tells us that there's 68% of your data between -1 and +1 standard deviation away from the mean, then 95%, then 99.7%, etc. 1, 2, and 3 standard deviations away from the mean. Now, one thing that's very helpful in working with the standard distribution, standard normal curve, or any normal curve, is to realize that they're symmetric. That line of symmetry there is going to be your mean. Now, for right now, we're going to work with what's called the standard normal curve, and I have my own notation for the standard normal curve. So, the standard normal curve, I have some of my own notation for it. It's going to be Z is distributed normal 0, 1, where this number is going to be our mean, that first one, and the second one's going to be our standard deviation. So in general, this is going to be your mu, that's going to be your sigma. But for the standard normal curve, for the standard normal curve, that's why I put it in caps here, the standard normal curve, those values, the mean and standard deviation, are set to 0 and 1. It's a very special one. The way that this is read is Z is distributed with a mean equal to mu. In this case it's going to be 0, and a standard deviation equal to sigma. And that sigma is going to be there. So in the case of the standard normal curve, those values are 0 and 1 respectively. Mu and sigma. Mu equals 0 and sigma equals 1 in the case of the standard normal curve. Okay, so a lot of information here to kind of absorb right away. And the good news is I'm not going to let up on that information. I'm going to keep it going. There's some Google Sheet commands that are going to help us calculate those things, and it's going to be a lot nicer than some of our alternatives. So let me finish going over this right here. The total area underneath this curve is equal to 1. That's going to become an important little feature here. We're going to take advantage of that repeatedly. And the standard normal curve, this is just a reminder here, has a mean of 0 and a standard deviation of 1. Your Google Sheets command that you're going to use in working with these areas is right here. Norm distribution, X, mean, standard deviation, cumulative. Now for this course, and unlike our work with the binomial distribution, cumulative will always be set to true. Always for this command. You're not going to use false ever. Even if you were to go on and take a degree in statistics, you probably wouldn't use that with false. Maybe there, but in any case, it's just not something we're typically going to do here or worry about in this class. Now this command gives you the area of, or underneath the standard normal curve to the left of a particular point. So that's what we're going to use it for, is finding areas. So finds area. And let's see what that's going to look like for this particular curve. It says find the area to the left of 0.93 under the standard normal curve. Now I want to start you off on a habit here that I would like to see you use a lot, and that is to think about what you expect here. Now, the standard normal curve has a mean of 0. So that means, different means, that number there is going to be 0. Now that midpoint tells you something about what kind of an answer to expect. And what I'd like you to think about for a second is this. Which one of these statements is going to be true? And don't shut out the answer till you think about it. The area, now I'm talking about the shaded area, will be less than 0.5. Or the area, and again the shaded area, will be greater than 0.5. And last but not least, the area, and again the shaded area, will equal 0.5. Which one of those do you think is going to be true? Think about it for a second and then see if your neighbor agrees with you. And then we'll take a look at the command that will actually be able to get that value from the normal distribution. So go ahead, chat it up with your neighbor real quick. Or talk about the Tigers game last night, or better yet, talk about the Tigers game on Saturday. Go Lions. Yeah. Okay.
Wait, so he's just
the shaded area, that's all this area to the left of 0.93. Let's see some hands. How many people think it's A? How many people think it's B? All right, so B's looking pretty good. How much area is to the left of 0? How much area is right here? 0.5. It's half of the area, right? The total area is 1, so each half of 0 has to be 50% of the area. We've shaded more than 50% of the area, right? So that has to be B. Your answer should be more than 0.5 when you find that area. Now, as far as finding that is concerned, our command is going to look like this. Equals norm distribution of our x value, which is 0.93. So 0.93, comma 0, comma 1, mean and standard deviation, and then true. So let's type that in Google Sheets and see what we get. Equals norm distribution 0.93, comma 0, comma 1, comma true. I'm getting about 0.8238. Is that what you're getting?
Yes.
0.8238. What if I wanted to find what area was here? How would I find the area in that yellow part of the curve?
1 is 0.93.
Well done. 1 minus that. So if I wanted to find that much here, it's going to be 1 minus 0.8238, or approximately 0.1762. And you don't have to do that subtraction manually or anything like that. You can just ask Google Sheets to do it. I've got it right here, equals 1 minus this cell. So, nice. And if you're looking at too many decimals, you're like, oh, that's just making me nauseous, then click this button, decrease decimal size. I think you have to work a little harder to find that if you're working off of a tablet, but you can kind of dial down the noise a little bit. I don't know, personally I sometimes get a little bit annoyed looking at so many decimals, so it's a little bit more user-friendly there. Okay, nice, nice. All right, comments on this one. Are you able to get these numbers off of your Google Sheets? Can I see some hands? Is that working? You getting those numbers off Google Sheets? No? Who's not? Okay. Okay. All right. You type it in, I'll be right back. Did you get it? You didn't raise your hand.
I did it.
Okay.
It's working.
It's working. See, it was just my mere presence here that
That's
solved it.
Wow, so magical.
Anyone else, carrots?
I just had a question. How did you get the 1 and 0?
The 1 minus the part? Oh, that's the mean and that's the standard deviation for the standard normal curve. Remember, the standard normal curve has mean 0, standard deviation 1, so it's always a
You won't be my witness. I'm gonna just hand you. Bless you.
Thank you. And then when you see it, tab key, because it finishes it for you and gives you a reference. And then you're going to type that in point line 3, point line 3, comma 0, comma 1, and comma true. Anyone else not getting that one? Okay, let's change things up a little bit. Example B here. Find the area to the right of negative 0.87. Let's play this game again. A, B, or C. Less than a half, more than a half, equal to a half. What are we expecting on this one? In terms of the area for the shaded region. Less than a half, greater than a half, equal to a half. What we got? Has to be greater than a half, right? Because the dividing line that mixes things up here is when x equals 0. And at x equals 0, you got 50% of the area to the right and 50% to the left. We've clearly got more than 50% of the area here just based on that value. Now here's the trick, or here's the thing to keep in mind. Google Sheets can only give you the area to the left. It's not going to recognize, gee, oh, you want the area to the right? It's not going to do that for you. It's just going to give you the area to the left. So I can start out this way. I can start out with equals norm distribution of negative 0.87, comma 0, comma 1, comma true. But that's not going to be the answer. What am I going to have to do to find the answer? Madison? Yeah, nice. So let's do that first answer. So equals norm distribution, negative 0.87, comma 0, comma 1. Oops. 0, not O. I don't think Google Sheets would like a O there. And I get 0.1921. Now that kind of makes sense. 0.1921. All right, I believe in that. Let me. I don't know. I'll see if this one works. 0.1921. But if I want the area to the right here, I'm going to have to take and subtract that value from 1. So this is approximately 0.1921. This area is going to be 1 minus 0.1921, which is going to be 0.8079. Thank you. Yay. Now, so there's a couple ways you can do that one. You could do it in kind of 2 steps, like we did here, or you can do it all in 1 step. So all in 1 step, it would look like this. You just type in exactly what we just did. 1 minus norm distribution. It's up to you. I have 0 preference one way or another for you to do it one way or the other, whatever you find most comfortable. But you should get, about the same thing that I'm getting there. Okay. Thumbs up on example B? Yes. Okay. Thank you. Let's make it harder. You guys are looking a little listless, so we have to make it harder. No? Ah, too late. Too late. I got that listless feeling from you guys, so that makes it up a little bit. Think on this one. What do you want to do here? So this one's a little bit different. We're trying to find the area between these 2 points on the normal curve. So between here and here, between 1.23 and negative 0.97. Now what's our game plan? Yeah, Garrett, want to give it a shot?
Find the area for the unshaded first.
Find the area for the unshaded first, like both of them?
Yeah.
The right one or left one or both of them? I mean, I guess you could find the areas for the unshaded ones. Sure. That, and then do what? One, if I had both of these areas, then what would I do?
I want to say add it together.
Add them together, and then what? And then subtract it from 1. If I had these areas, and I found each of these areas, add them together, subtract from 1, that would leave me with this. Because remember, the total area is 1. If I subtract off the piece I don't want, then I'll have the piece I want. So, but there's another way to do this one. Somebody else had a hand up. Evan?
You take it from the right side and subtract the left.
Yeah. Let's keep in mind how Google Sheets is going to work. Google Sheets, Amy is going to give me the area to the left of this. And if I subtract off the area to the left of this, what's going to be the remainder? Well, whatever's in between here is going to be what's left over if I take this area minus this area. So that's probably the most efficient way to do it. There's nothing wrong with what Garrett was suggesting, but I want to leave you with the most efficient way that I can think of, and that would be norm distribution and I'm kind of leaving some breadcrumbs here for you to kind of see where things are coming from the 1.23 comma 0 comma 1 comma true minus norm distribution comma 0 comma 1 comma true. This time I need to put in the negative 0.97. Negative 0.97. And that's how I'm going to get the area between those 2 curves. Now, unfortunately, unlike the last couple, we can't look at this and say it should be more than 1/2 or it should be less than 1/2. We just don't know. We don't have this on one side of 0 or the other. So we're just going to have to trust to plugging in the right way to begin with. So you can split that up into two pieces. You can find the area to the left of 1.23 in one cell, to the left of negative 0.97 in another cell, and then subtract them. Just do one minus the other. Nothing wrong with that. You can do it all in one command. So you could take, and let me just copy this just to be lazy, could take that and subtract, I don't want to do that one. Let's see. I want to subtract off that other area, which is area to the left of negative 0.97. You get the exact same thing. I don't know. What way works best for you guys? Do it all in one or separate cells? What do you like best? All in one, separate cells. All right. So mixed bag, but you know, I think I heard a little bit more of separate cells. That's fine as well. But notice, I mean, the important thing is you get the same answer either way. So you just got to find something that's convenient for you. Are you all getting that right answer on example C here? Finish this one. Finish this one. Okay. Amy? C, express confidence. You need to open up the worksheet. Just any worksheet, doesn't have to be. Probably do all one. Colin, good? All right. Let's move on to example D here. And in example D, you get to start out by deciding which one of these graphs actually match the requested probability. So we're looking for the probability that if we had a random variable which was normally distributed with a mean of 0 and a standard deviation of 1, that is the standard normal distribution, which one of these, column A, B, or C, which one of these graphs corresponds to that probability? Which one? Looks like it works. Got a couple answers here. Hold on, gentlemen. So what are you guys liking for this one? A, B, or C? C. C? Lots of C's. So let's see what's wrong with this one. What's wrong with A here? What's wrong with A? How come this isn't the probability or the area between negative 2.01 and negative 0.92? What's wrong with it? It's actually shaded to the left of negative 2.01. I didn't ask for that part. The problem is asking for just the area between negative 2.01 and negative 0.92. Here, in problem part B here, or answer B, it should be this part that's shaded, not the part that's in the tail. So the one that actually works is this one, where you're just shading between these two little pieces right here. Now, you're probably not going to get a huge probability, but we're going to calculate that nonetheless. This is where you pick up the ball and run with it. Find that probability. Ooh, I made a mistake here. Can anyone see my mistake?
Negative area?
Other way around.
Yeah, I got these backwards. You got to subtract the left from the right. I've got the right from the left. But let's actually go through this and see what you might see if you made a similar mistake and how you can catch your mistake. Mhm. Yes, sir.
So you always subtract the right one from the left one?
The right one minus the left one, yeah. So these are backwards. So let me fix that. It should be negative 0.97 and negative 2.01. But it's not like you can't recover from this kind of mistake. But you should see it's a mistake really quickly. What about this tells me that I made a mistake?
Negative.
It's negative. What are probabilities between? Probabilities 0 and 1. Area underneath the curve, underneath the standard normal curve is between 0 and 1, just like probabilities. So the fact that we got a negative here is saying, yeah, there's a mistake. You're not going to get a negative probability. You're not going to get a negative area between these two. And my mistake is that, whoops, I got these backwards. So let me fix that here. So you don't need to fix it. All you need to do is, just drop the negative sign. That's fine. There's going to be stuff like that. Negative 2.01. So there we go. That looks a little bit better. Maybe you feel better doing it that way. So about 0.1438.
Mr. Barrett,
Yes.
I think you put in 2 or 7 instead of 2 for.
Did I put in the? Let's see. Oh, that should have been a 2. Thank you. Let me change that one over here. 2. Perfect timing. Thank you, Liv. So about 0.1566. Is that what you guys are getting? Yes? Yes, I'm looking. Yeah, who, me? I love that.
Oh, yeah.
Yeah, okay. Quick joke. An English professor is getting angry at one of her students because she's text messaging and points at the student and says, "You, give me 2 pronouns." The student says, "Who? Me?" Ba-dum. All right. I'll keep my day job. All right. So what was our answer? About 0.1566? Yeah, 0.1566. 0.1566. All right, looking good there. In case you're like glazing over a little bit, you're like, oh God, this is such pain. Let me show you what we used to have to do for this kind of stuff. Yes, yeah, just so you can feel good that we have Google Sheets and other technology.
Tell the school both ways.
Used to
Airplane
be,
in the snow.
yeah, that was back when I would do those kinds of things. So it used to be you'd have these tables. If I wanted to look up, for instance, the area to the left of negative 0.97, here's what you'd have to do. You'd have to regard that area as being the 0.9 is right here. So the negative 0.9 is there. And then you'd have to go over underneath the 0.07 column, move down to negative 0.9, and find your area there.
This is our math homework. This is what was in the homework.
We've got Google Sheets. Got Google Sheets you can do that with now.
Yes.
So you can feel good about that. We are not going to be doing this with the tables. The author actually emailed me one time and said that he keeps this in the hard copy of the book because there's a few old timers that still do it this way. Fortunately, your instructor's not one of them.
Thank you. Yes.
Yes. So, and this isn't the only table that you're going to have to work with or would have to work with. I used to have to print out dozens of sheets because we had a T table, a Z table, an F table, a chi-square table, table for regression, table for the sign test. So that's like 6 of them off the top of my head, and I'm sure I'm missing a few. There's tables for all kinds of different distributions. Fortunately, I don't do that. I want you to understand some of these things, what they are, including some notation that we're going to work with in example E here. Before I get to notation, thumbs up on example D. Some thumbs up. Yes, Vlad? All right, thank you. Now, this notation is notation that's going to follow us for the rest of the course. And that is Z sub alpha. And we're going to see it with T values, with chi-square values. They're always going to have the same kind of meaning. So Z sub alpha. Let me draw this for you. Okay. Z sub alpha is going to be the point on the normal curve with alpha percent of the area in the right tail. Now it's important that it's the percentage of area in the right tail. It's always in the right tail. So let me show with you, the drawing of a couple of values. Let's see here. Let's do this one. Let's do Z sub 0.05 is a common one that we have to find. Z sub 0.05. That's going to be the point with 5% of the area in the right tail. Okay. I could also have, let's do Z sub point, we'll do 0.83. Yeah, I'm an artist. So Z sub 0.83 is going to have to be over here in the left tail because 83% of the area is going to be to the right of Z sub 0.83. So it's always talking about the area in the right tail. Now, unfortunately for us, Excel and Google don't exactly work this way. They're going to return values with the appropriate command. They're going to return values in the left tail. So we're going to have to kind of tweak things so that we get what we want, not what they want to give us. All right, so let's start with example E here. So we've got this Z value. And in order to write it with this notation here, what we need to figure out is how much area is in the right tail. How much area is shaded. So how are we going to work on that? Well, it's going to start with figuring out what area is to the left of negative 0.81. How come I got to start out there? How come I can't just, find this right off the bat? Remember, Google Sheets only works with the area in the left tail. So that's where you're going to have to start out. So I can find the area in the left tail this way. Norm distribution. Royale, maybe you can help me figure out the rest of this command. Well done, thank you. comma 0, comma 1, comma true. Now that's going to give me the area in the left tail. And that's fine. But that's not what I want. I want to find the area in the right tail. So Royale got us more than halfway there. How do we finish this up? What are we going to do? Liv?
Do 1 minus that?
Yeah.
Oh,
So let's find that area first, and then I'll do 1 minus that. So it's going to equal norm distribution, negative 0.81, comma 0, comma 1, comma true. Equals 1 minus, bam. So I get 0.7190. So this area in the left tail was 0.201, and then we'll subtract from 1 to get the area in the right tail. So that was 0.201. That's going to be 0.79. Now, is that right? 7910? No, that doesn't feel right. 1? Yeah, 10. Oh. Yeah, okay. I'm sorry. 7910. No, I'm just 7910.
He's calculating.
I must have copied something wrong. This doesn't feel right.
It's supposed to be 8, 9.
2090, that one.
90. That's where my mistake is. I'm like, wait a minute. This should add up to 1, and it wasn't. All right, 2090. Thank you. Now we found that area, but remember the question was to write this using this notation. So the area in the right tail tells you what's going to go here. This is going to be z sub 0.7910. And if you didn't write the 0, I'm not going to complain. I'll write it because we calculated it, but that's your z sub alpha notation. Now, if you're wondering, it's like, well, gosh, he's really taking a lot of time with this. You're right. You're going to see this calculation a lot this semester. You're going to have to understand this notation. And it's going to be tempted to think that, gee, it's, it's the area in the left tail because that's the way Google Sheets works. No, it's not. It's always the area in the right tail when you're looking at these kinds of notations. Now, a lot of times you're going to start out with an area and then want to get the z value. So I might start out and say, oh, I want the point that's got 5% of the area in this tail. What is that point? So we're going to work on that part next, and that's going to involve a different command from Google Sheets. Of course. Derek?
How did you get 0.79 again?
Sure. So first I found this area in the left tail, which was 0.2090, and that's the area in the left tail. Right there. That's what my Google Sheets command gave me for this. And then to find the area in the right tail, I just did 1 minus the 0.2090, and that gave me my 0.7910. Remember, that 1 is coming from the fact that the total area underneath the curve is 1. So if I subtract off that part, the rest of it is going to be my 0.7910. Appreciate the question.
The alpha part will always be a positive number, right?
The alpha part has to be a number between 0 and 1. Has to be a number between 0 and 1. Yeah. Now, as far as this value itself, this value can be left of 0 or right of 0, so it could be negative or positive. And if you look at ladies, if you look at this picture here, for example, I, what you'll notice is that you have values that are actually symmetric. So, for instance, we'll do example H in just a minute, but you'll have symmetric values here. So z sub 0.03 could be here, And the negative of it would be here. They're going to be just opposite values, but the notation is a little different. I mean, you've got a negative here, you've got a positive here. You could write this as something a little different, and we'll discuss that after we do example H. Let me give you the new command that you're going to need here. Now, what was my promise to you about these commands relative to the exam? What did I promise about these types of commands relative to the exam? Make you memorize them? No, that wasn't my command. No. What did I say then? I'm going to write these commands on your test. You're not going to have to look at the board. You're going to have them right on your test. This is not a class about learning Google Sheets. All right? We are going to use a lot of features from Google Sheets. It's cool that you're understanding more about spreadsheets, but it's not a class about remembering these commands. I will give those to you, so don't stress about that. That's a promise. If you're going to start out with an area and find a z-value or an x, we'll call it a z-value for now, then you're going to use the norm inverse command. So let me just kind of write here in general what happens. Start with an area and output a z-value. So that's what this norm inverse command is doing. It's doing the opposite of what our norm distribution command does. And you're going to have to keep those things straight. So you're going to have some percentage, as a decimal. That's going to be your P. That's going to be the area. So that's the first part here. P is the area in the left tail. Then you're going to have a mean, mu, and a standard deviation, sigma. And this will put the output, this will give you a value on the x-axis or z-axis, depending on what you want to call it. And that's going to have that amount of area in the left tail. So that's our new command. Let's take a look at how example H pans out. And let me draw example H here for us. Now, a lot of times on the exam, I'll actually draw for you blank normal curves and ask you to shade that kind of stuff in. And it's to guide your thinking, help you be critical of your answers. I want to find z sub 0.03. Z sub 0.03 is going to be the point on the normal distribution, standard normal curve, with 3% of the area in which tail? The right tail. All right, so I want 3% of the area in the right tail. So that's going to be this point out here someplace. So if 3% is in the right tail, then what percentage of the area is in the left tail? Try again. There you go, 97. 97% of the area is in the left tail. And you have to figure out the area in the left tail because that's how this command works. So it's going to equal norm inverse of 0.97, comma 0, comma 1. The good thing for this command is that you don't have to use that false or that true or false like we had to for some of our other commands. It's just these things. It's your P, it's your mu, it's your sigma. So that 0.97 is coming from right here. Now there is another way to do this. If you're looking at that and going, yeah, I don't know, that's some tough arithmetic there. If you're not really crazy about the arithmetic, you can also do this. You can make Google Sheets do your arithmetic for you. And there's nothing wrong with it. I'm not going to be looking at your Google Sheets and going, yeah, you didn't do that in your head. I don't care. I want you to get it right. That's all that matters. You can let the Google Sheets do that part for you. Say, oh yeah, do 1 minus 0.3. And the comma 0, comma 1. It'll give you the same answer either way. Let's try that here. So this is example G equals norm inverse of 0.97, comma 0, comma 1. Or I could do it as norm inverse 1 minus 0.03, comma 0, comma 1. And I get the same thing. So it's up to you. Whatever you find most convenient, doesn't matter to me. Let's try a couple more here. Example H. So the next one I want to try is Z sub 0.17. Now I just draw these things and I ask you to draw them to have a good reference. So that, you know, you're not going to catch minute mistakes, but you can catch big mistakes. So I got a 0 here. What's the Z sub 0.17 mean? What am I asking you to find relative to the normal distribution, the standard normal curve? Brandon?
17% of the area in the right tail.
17% of the area in the right tail. Should I be drawing Z sub 0.17 here or Z sub 0.17 on the left side of 0? Which side of 0 should I draw it on? The right side. It has to be on the right side, correct? Because if it was on the left side, then more than 17% of the area would be in the right tail. So let's draw that on the right side. Now, am I taking care to draw it exact? No. The thing that I want to make sure of is that it's on the proper side of 0. So that if you use the wrong numbers and you get a negative number, hopefully you'll look at that and say, oh, there's a mistake. I should get a positive number. So Z sub 0.17. Now if I do Z sub 0.17, how much area is here if I have 17% of the area here? How much area is there? 83%. So 0.83. So a couple choices for you. Norm inverse. I would just kind of do it directly. And get 0.83. So norm inverse there should give you about what, 0.9542? Where I care about it on an exam, I'll tell you how many digits I want. Typically for these, probably 4 maybe, not sure. You could have also done 1 minus 0.17 if you didn't feel like doing that arithmetic in your head. That's okay. Let's see about something else here. Kind of going off script for just a moment. What if I asked you to find Z sub 0.83? Let's draw that one for a moment. see, that's a little too low here for my purposes. So, where am I going to draw z sub 0.83? Is it going to be to the left of 0 or to the right of 0? Z sub 0.83 is going to be what? How much of the area is going to be in the right tail? 83%, right? So if 83% is in the right tail, I've got to be past the 50% line. I've got to be to the left of it. So it's going to be z sub 0.83. Can anyone see something that might save us some time on this problem? Okay. Well, let's keep going. So I've got this area in the right tail. That's 0.83. How much of the area is going to be in the left tail? 17%. 0.17. What command am I going to use to find that? Norm distribution, not norm distribution, norm inverse. Norm inverse. Mason, finish it off for us, please. Norm inverse of what?
0.17, 0, 1.
Perfect. Find that number. See what you get. Does anyone get anything that, like, oh, well, that's odd? It's negative. Good. Does anyone see anything familiar about that number? Yeah, it's the same number but negative from up above, right? These two are pretty close. You're still looking at the same area in the tail. It's just that one time you're to the left of 0, one time you're to the right of 0. And that goes back to this idea right here, that you're going to have symmetric values on either side of this distribution. So sometimes if you make a kind of mistake, sometimes you can say, oh, well, I'll fix it by taking the negative or taking the positive, depending on the problem. But you are going to get symmetric values on either side of 0. So for instance, earlier we found that z sub 0.03, and I didn't write it down for myself here, let me write it down, or z sub 0.03, that was, that's not that one, is it? No, z sub, no, it was example H, equals norm inverse of 0.97, comma 0, comma 1, 1.88. So that was 1.88. On the other side of this, I'll have negative 1.88, and I can also write that with Z notation. It's negative of this, but you could also say it's positive z sub 0.97, because 97% of the area is going to be to the right of that point on the z distribution. All right, I sense a silence in the crowd. Is it getting
No.
too weighty? Too easy? I should make it harder?
No.
You're sure?
We can
All right.
start talking if you want.
Let me talk about statistics a little bit. There is something I've been meaning to try and get to you, but it just hasn't happened. As it stands, I don't know if you guys are realizing it, but we're going to get behind today. I'm not going to try and squeeze in section 6.2 because I wanted to spend more time on this here. first before we do section 6.2. So might not seem like it, but I am taking my time through this material here. Yeah. All right. Great. Sort of. Yeah, maybe. Yeah, rah. All right. Let's keep going. No, part of the reason I want to spend time on this is because finding these numbers is going to be important the rest of the way. And I don't want you to struggle moving on finding these numbers. So, yes.
Okay, so the Z alpha score is like a representative of the percentage of the area. So like
Z sub alpha is going to be, yeah.
In general, right? So Z sub alpha.
Z sub alpha is going to be the point that has that much area in the right tail.
Okay.
And that's going to be a value that we're going to get on the x-axis or z-axis, depending on how you want to call it. But it's going to be a value. In fact, you kind of reminded me of something I wanted to write for you guys, which would be this. Just to kind of have this in one place. Norm distribution, you're going to input the x and output the area. So that's what your norm distribution command does, is it takes a value on the x-axis and it outputs an area. You could also think of that area as a percentage or probability. But that's what that area is going to represent in a lot of cases, a percentage or a probability. In contrast, your norm inverse is going to input the area or probability and it's going to output the value on the x-axis or z-axis. So they're doing exactly opposite things of each other, and it's appropriately named. One of them is the exact inverse of the other one. You're just switching the roles of the input and output. All right, so it's going to take a little practice. But like I said, on the exam, I will have the general form of these commands, so you can kind of go back and remind yourself of what's what if you need to, and of course how you find those values. Let's try one more with one of these Z sub alphas here. Let's try Z sub 0.062. So Z sub 0.062. No, Z sub 0.62. That makes a difference. Let's put that decimal in the right spot. Z sub 0.62. Got my 0 here. I want you to think for a second about where we should put this value. Am I going to write it to the left of 0 or am I going to write it to the right of 0? Think for a second. Where is this going to be, that Z sub 0.062? Liz says to the left. Why is she right? It's more than a half. Half of the area is to the right of 0. If I've got more than half of that area, it has to be to the left of 0. So, thank you. So, Z sub 0.62 is going to be right there. I'm going to shade the area to the right. That's what we're looking for. But that's not how we're going to find it. What are we going to do to find it? So I got 0.62 here, that's not how Google Sheets is going to work. What do I have to do to make this work? I'm sorry. What do I have to do to find this one, this area? Well, our norm inverse command starts out with an area and outputs a value on the x-axis, which seems like what we want because we're looking for this value that's on our x or z-axis, depending on what you want to call it. Now I got to input an area and output that value, but what area should I input into that? Some help?
0.38.
Yeah, that's going to be your 0.38. 1 minus 0.62 equals 0.38. That's going to be the area here. Google Sheets works with the area in the left tail. So norm inverse of 0.38, comma 0, comma 1, that's going to give us our correct z value. Let's see what that will be. And I'm just going to make that a 0.38. Does it make sense that it's negative?
Yes.
Yeah, we expected it to be negative. And what I'm trying to get you to do is really be kind of critical of your answers here so that if you get something that's positive and you expected something negative, that you're going to go back and fix it. So negative 0.3055 is approximately the correct z value here. Negative 0.3055. Okay. Whew. Let me ask a little follow-up question here. Well, not exactly a follow-up, kind of a lead into the next one. P sub 0.99. Remember what this is? Percentiles. What would it separate? What's P sub 99? Do you want your SAT score, assuming you want to do well, do you want your SAT score to be in the 99th percentile or in the first percentile? 99, yeah. You're separating yourself from the bottom 99% and you're in the top 1%. So let's take a look at P sub 99. Where should I draw P sub 99 to separate the bottom 99% from the top 1%? Am I going to do that in the left tail or should I put it in the right tail? Where am I going to separate the bottom 99% from the top 1%? Top 1% is going to be in which tail? Left or right tail? The right tail. So that's going to be, the top 1% is going to be right over here. So that's going to be P sub 0.99 separates the top 1% from the bottom 99%. So 0.01. Now, think about the Z notation. What should I write here if I'm going to write it in the form of Z sub alpha? Is she right? Z sub 0.01? Yeah, Z sub 0.01. That's going to be the same thing as this. So, okay, we want Z sub 0.01. What do I have to look up on Google Sheets in order to get Z sub 0.01? Am I going to use, let's start with this. Am I going to use the norm distribution or the norm inverse command? Which one do you think? What are you inputting? Are you inputting an area or are you inputting something from along the x-axis? We don't have something on the x-axis. What we do have is an area, right? So if that's going to be your input, which one of these do I want to use? Do I want to use norm distribution or norm inverse? Inverse. Inverse is where you input the area, and then you output a value on the x-axis. So equals, well, this is just the notation for it. It's not the actual value, right? We're going to get the actual number when we do the norm inverse command of 0.99, comma 0, comma 1. And that should give you about 2.33. I used to have these memorized a little bit better when we had to use the tables, which was just awful, but it was what we had to do. Could someone double check me? We're getting about 2.33 there. Amy?
Is it just 0.99 or 1 minus 0.99?
It'd be this, if you did 1 minus 0.99, then you could be getting 0.01. That's kind of an interesting question here. If you did 1 minus 0.99, you'd get negative 2.33. You'd be finding the area with 1% of the area in the left tail. So that value would actually be the first percentile, P sub 0.01, or Z sub 0.99. And that's going to be opposite of this over here because the distribution is symmetric.
Oh, so it's the same number but negative.
It's the same number but negative, exactly. And I think I showed this before, you do have that kind of symmetry on here. So it's not surprising that you can get at the same result in a couple different ways, especially if you're willing to just flip a negative sign. Yeah, good question. Okay, let's do one last one here. Find the 10th percentile. So this is the one that separates the bottom 10% from the top 90%. 10th percentile. This is not necessarily the place you want to be if you want bragging rights and you're in a race, right? So 10th percentile. Let's see if we can't do that one. I'm just going to draw it right here. So that one's going to be problem 38 here. Got a 0 there. Try and think we're going to draw the 10th percentile. P sub 10. The bottom 10% are going to be in the left tail. That's going to be here, P sub 10. What's the proper notation for our Z? What would that be? Z sub what? 90. Nice, thank you. Who got that one? All right, Z sub 90, because 90% of your area is going to be in the right tail. But there's good news for us. To find P sub 10 or Z sub 90, what norm inverse command am I going to issue? Norm inverse of what? Yeah, 0.1, comma 0, comma 1. And yeah, I'm not sure about this one. Negative 1.65? I don't know. We'll have to find out. Equals norm inverse 0.1, comma 0, comma 1. You can't hurt until you leave class. Negative 1.28. Why is it negative? it has to be to the left of 0.
Oh, okay.
To have 90% of this area, you've got your 50% here, and then 40% here. So that's pushing you to the left of 0 to have that 90% in the right tail.
Shouldn't it be under 1 though? Because it was negative 1.28.
Say again?
I don't know, man.
The middle is 0, so negative 1.28 is to the left.
Yeah, it has to be to the left of 0. So I'm not sure what you mean by under 1. Okay. All right. You come talk to me afterwards.
Okay.
All right. I think we're done here. Christine, yes, question?
The answer we find is the z-score?
Yeah, this is a z-score. So that's your negative 1.28 right there. So there's our z-score. Anything else?